Today we're going to be proving that a quadrilateral is a parallelogram. So theorem 6.5 states that if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if I know that these opposite sides are congruent, and I know these two sides, opposite sides are congruent, then it's a parallelogram. Theorem 6.6, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So if I know my two angles there are congruent, and I know these two angles are congruent, then I know this is a parallelogram. Theorem 6.7, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if I draw in both of my diagonals, and if they're being bisected, so that means they're cut in half, then I know I have a parallelogram. Theorem 6.8, if one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. So if one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. So if I know that this set of opposite sides are congruent and they're also parallel, then I know I have a parallelogram. So for example 1, it says the length of ON is 4x minus 6, LM is 3x plus 5, NM is x minus 4, and OL is 4y minus 3. And I also have that my angle O is 3z plus 10. Angle M is 7z minus 34. I want to find the values of x, y, and z for which LM and O must be a parallelogram. Well, if this is a parallelogram, then I know that ON and LM are congruent to each other. So that means 4x minus 6 equals 3x plus 5. So when I go to solve this, I'm going to subtract 3x to both sides. So 1x minus 6 equals 5. Add 6 to both sides. X will equal 11. So to find y, I know that the length of OL is congruent to the length of NM. So that means 4y minus 3 equals x minus 4. So when I go to solve this, I can't solve it because I have two variables. However, we just found that x is 11, so I'm going to substitute that in. So now I have 4y minus 3 equals 11 minus 4. 11 minus 4 is 7. So if I add 3 to both sides, I get 4y equals 10. Divide both sides by 4. Y equals 2.5. So now lastly, we need to find the value of z. And since this is a parallelogram, that means my opposite angles are congruent. So that means 3z plus 10 equals 7z minus 34. So if I subtract 3z to both sides, left with 10 equals 4z minus 34. I'm going to add 34 to both sides. So now I have 44 equals 4z. Divide both sides by 4. Z equals 11. So now for example 2, it says the length of OH is 2x minus 7. So this length right here is 2x minus 7. OF is x plus 3. Then it tells me the length of EG. So this whole diagonal from E to G, that is 4y minus 2. It's not the angle, that's the diagonal. And OG is y plus 10. So I want to find the values of x and y for which EFGH is a parallelogram. So if I'm looking at diagonals, for it to be a parallelogram, that means my diagonals are bisected. So that means that OH has to be congruent to OF, EO is congruent to OG. So if they're bisected, then I have that. So if I go to write out some equations, I know that these two are equal to each other because this diagonal is bisected. So 2x minus 7 equals x plus 3. So if I subtract x to both sides, I'm left with x minus 7 equals 3. Add 7 to both sides, x equals 10. So then now we need to find the length of y. So for this one, I know the whole diagonal is 4y minus 2. If OG is y plus 10 and this is congruent, that means EO is also y plus 10. So if I take both of those segments of my diagonal, they are the exact same. And if I add them together, they're going to equal the whole length, which is 4y minus 2. So I have 2y plus 20 when I combine like terms. Y plus y is 2y, 10 plus 10 is 20, and it equals 4y minus 2. So I can subtract 2y to both sides of my equal sign. So I'm left with 20 equals 2y minus 2. Add 2 to both sides of my equal sign. 22 equals 2y. Divide both sides by 2. Y equals 11. So I found x, I found y. Now we can look at example number 3. So with example number 3, I changed this part of my diagonal to be 49. This one is 3y plus 3. This part of my diagonal is x minus 11. And this part of my diagonal right here is 5y minus 6. So if I go to solve this, because I'm looking to see that ABCD is a parallelogram, so that again means my diagonals are being bisected. So that means these segments are congruent and these two segments are congruent. So if I go to write out one of my equations, if I'm going to solve, I'm going to start solving, let's find y first. So if I have 5y minus 6, that's going to equal the length of 49. So if I add 6 to both sides, I have 5y equals 55. Divide both sides by 11, or 5, sorry, and y equals 11. So now if I want to find x, I'm going to be using my other diagonal, which is also bisected. So I have 3y plus 3 equals x minus 11. So I cannot solve it as is. I have an x and a y, but I just found that y equaled 11, so I'm going to substitute that in. So I have 3 times 11 plus 3 equals x minus 11. 3 times 11 is 33, plus 3 means I have 36. So then if I add 11 to both sides, x will equal 47.